Hello everyone and welcome to this segment of the Trinity TI training module where we'll cover off the plumbing. My name is Andrew Smith and I'm the training manager here at NTI and I hope you enjoy this segment. There are a few different ways the TI can be configured depending on whether it's being used for heat only, with an indirect, or as a combi. The standard unit is designed to operate in a hydronic heating system and can also function with an indirect water heater. The combi version includes built-in components allowing it to deliver both hydronic heat and domestic hot water. In any case, water quality is something that needs to be taken into account. Water hardness levels in excess of 9 grains per gallon hardness can cause damage to the heat exchanger of the unit. So what we do at NTI is we include a bottle of inhibitor with every boiler, and we suggest treating the water in every installation, regardless of hardness level. In cases where the water is not excessively hard, there's really no downside in using the inhibitor. But in cases where the water is quite hard, the inhibitor will help prevent limestone and magnetite deposits. Hot water boilers are designed to operate with airless water in the system, so an air elimination device of some sort needs to be installed in the system to remove air from the water as it circulates through. It's recommended to include an air eliminator on the secondary system as well. A 30 psi relief valve is included with each boiler, but some models are rated to either 80 or 145 psi. You can check the rating plate on the heat exchanger to determine the exact rating of the model you are working with. In instances where the heat exchanger is rated to 80 or 145 psi, a higher psi relief valve can be used instead of the 30 psi version included with the boiler. Many local codes require the use of a low water cutoff or flow switch. If local codes don't dictate the requirement of such a limit, NTI requires the use of a low water cutoff whenever there's radiation below the level of the boiler. However, it is considered good practice to include a low water cutoff on all installations regardless of code. When installing a low water cutoff, it's preferable to use the 120 volt version wired directly into the boiler's main power supply. This will ensure that power is cut off completely in a low water scenario versus just killing power to the burner and leaving the potential for pumps to continue to run with no water. When installing the low water cutoff, you should make sure that the water line of the low water cutoff is at least 6 inches above the top of the boiler and that there are no valves between it and the boiler. The Trinity Ti is to be used only in a primary-secondary pumping system. This is to avoid cycling problems in systems that have poor flow or with heating zones that have very small capacities. Also, the flow requirement of the boiler is unlikely to match the flow requirement of your zones, so you need to decouple the flow between the two systems, which is done using a primary-secondary plumbing configuration. A primary loop needs to be used in all cases, regardless of the configuration of the secondary design. The design of the TI makes it a little more restrictive than conventional boilers, and there can be a tendency to underestimate the size of the pump required on the primary loop, including the pump used for an indirect. Because of this, NTI has laid out minimum pump sizes for each model, which can be found in a table on page 13 of the installation manual. It indicates a specific model across 3 different pump manufacturers for each TI model. These are the minimum size pumps that should be used for each the primary pump and the domestic hot water pump when using the boiler with an indirect. The chart also shows the minimum flow rate for the primary loop, the restriction head loss for the boiler itself, and the recommended size pipe to be used for the primary loop. When using glycol, there are a couple things to keep in mind. You shouldn't exceed 30 to 35% glycol in the system, and if you are using a glycol that has a built-in inhibitor, as many of them do, then don't use the inhibitor that we include with the boiler, because the two of them will actually cancel each other out. As previously mentioned, the TI needs to be installed with a primary loop. There really isn't any preset configuration the primary loop needs to be, so how it's configured is entirely up to the individual installer. This slide shows an example of a primary loop taken from page 16 of the installation manual, but it doesn't necessarily have to look like this. This is just an example. When building a primary loop, there are a few key things to keep in mind. The pump size and the pipe diameter need to match at least the minimum that is recommended in the manual. And the T's that go off to the supply and the return of the secondary need to be close together. They shouldn't be any further than 12 inches apart, but really the closer the better. And you need to make sure the pipes are well supported so the boiler isn't carrying the weight of the piping. So here's an example of a primary loop with an indirect, which doesn't actually show the indirect, but it would be placed where the arrow labeled optional indirect is pointing. In this case, you'll notice the addition of a second pump, which acts as the pump on a domestic hot water call. The important thing to remember in this scenario is that you want the loop to the indirect to come off the primary before the primary pump. When there's a call for domestic hot water, the controller will engage the domestic pump and not the primary pump. So in that case, the primary loop will actually be looping through the indirect and back to the boiler. In this case, the primary pump does not come on, only the domestic pump. And after the boiler water travels through the indirect tank, it then connects back onto the primary loop after the return from the secondary. And remember, the domestic pump needs to be at least the same size as the minimum requirement for the primary pump, because not only does the domestic pump need to handle the head loss of the boiler itself, but also the head loss from the indirect. In terms of how to lay out the piping for the secondary, it's really up to the individual installer and determined by the needs of the particular job. The installation manual lays out a couple of the more common ways of laying out the secondary and shows how it's attached to the primary loop using the closely spaced T's we discussed earlier. This example shows the use of zone valves, so there's a single secondary circulator that will come on with every heating call. Depending on the size of the pump, this may be powered by the blue wire from the boiler itself, or may need a relay between the primary and the secondary pumps. Remember that the boiler itself provides 3 amps. This slide provides another example of a basic layout of the secondary heating system attached to the primary using closely spaced T's. This example shows the use of zone circulators, so there isn't a single secondary pump that will come on with all heating calls the way there was in the previous example. In this case, the individual zone circulators would be powered through a multiple zone pump controller. And that concludes this segment on plumbing. I hope you found it helpful. Thank you very much.